All right, good morning, everybody. And there's the fifth. Everybody is here. And everybody is online, which means I don't have to get up. Please do turn on your cameras then. I can see and talk to you. I guess I can take this off for a while. Okay. We've got a really interesting topic for today, which you all should have read about and taken notes on prior from the coolmath.com about the idea of a tangent line, right? So let's start taking a look at that idea. This worksheet will serve as the basis of our work today, although I'm modifying it a little bit. And that modification is going to make things easier. But I want you to take a look at this graph here. I want you to imagine I asked a ridiculous question, such as, what is the slope of that graph? You couldn't answer it. There is no one number. You're like, but it changes. It's like getting steeper and steeper as it goes, right? And this is a question that you will have to answer in calculus. What is the slope of that graph? At a certain point, right? You can't tell the whole graph because it's different, but you can look at a particular point, and that's what a tangent line does. A tangent line, if you recall from geometry, is like any true line is perfectly straight, and it touches the graph at exactly one point, okay? And so if I were to zoom in and zoom in, as far as possible, we would get as close as possible and touch it just once. Okay? This line here is not a tangent line because it touches the graph 2 points. One here and one there. So that would be a secant line. Why they call these tangents and secant, I don't know, that's the name we have for it. So if a line touches the graph in 2 places, it's called a secant line. 1 place, it would be called a tangent line. Now, somebody's looking for this in student for the next period. Anyways, so what we're going to do on this worksheet is we're going to start trying to calculate that slope of the tangent line by using a really close secant line. So reading these directions, they say we have the graph of the function f of x equals 2 to the x. So this is an exponential function. We'll do some more with exponential functions later. Using a straight edge, draw a tangent line as accurately as possible at the point 1, 2. So they're looking for this point 1, 2. They're looking for that point right there. So that is our goal. We want to make this tangent line. And we want to calculate the slope of that. Well, once you've drawn in your line, you can calculate the slope based on any line on a graph, right? We can come in here and be like, oh, well, it crosses that intersection, and we can use that rise over run and calculate the slope then of the pink line. And we want to see how does that compare to something close by, a secant line through points 1, 2, and 2, 4, right? So a secant line from 1, 2 to 2, 4, let me use yet another color here. From 1, 2 to 2, 4, so that would be through that point there. So if I was to connect those 2 points, how does that change? You can see this one definitely looks a little steeper than the pink one. So we expect a bit of a difference there. Okay? Question is, how much of a difference is that going to make? And can we rely on that difference for our calculations going forward? Can we use that? Is there a general rule we can discover that will allow us to get the slope of that tangent line every time? Okay. Eddie, you're a little early. This is PreCalc.
Oh, my bad.
Not a problem, you can hang out. All right. Some people just really want to learn that pre-calculus stuff, right? All right. So that's the nature of this worksheet. Okay? And it's not excessively long, right? Again, you're calculating the slopes of a few lines. And then in the next page, it'll have you do it again, but closer. So notice that this graph includes teeny tiny tick marks for you. So you can get really close. You can start going like, okay, what about a line from here to there, right? How does that compare? You can zoom way in. But this is great if you have an iPad to use, right? Have an iPad. So instead, here's the modification I'm going to make. We're not going to do things on the worksheet. We're not going to do this by hand. Instead, I invite you to go to Desmos. I have the app around here somewhere. And you're going to let Desmos do the calculation, or at least the graphing for you. So we can write in y equals 2 to the x. There's our exponential. Okay. We want a line that goes from, what was it, from point 1, 2 to point 2, 4. Okay. So create the equation of a line that goes there. We need, let's say, from 1, 2 to 2, 4. That's a rise of 2 over 1, so it's a slope of 2. There we go. Right? So use Desmos to help you create your graph, and then you can see these exact intersection points. And that ought to help you make those calculations a lot faster. Questions so far? knows what they're looking for? Good, then have at it. I introduced a tool to my geometry students. You might be interested in this. You can just type up your answers to the worksheet on a Google Doc, if that'd be easier for you. Or you can use there's a Chrome extension called Commie, and this will allow you to actually annotate PDFs. So if you were to install this, let me get you a picture of it here. There you go. Right? You can open up the worksheet in Commie, and then you could, in fact, actually draw on it. There's a line tool you can click and drag. It's not as great as doing it, with an actual pencil or stylus, but better than nothing. And highlight and type in right on top of it. If you want to try that, you certainly may. But a Google Doc typed answers is just as well for now. Right. That's all the information I have for you. We've got 6 questions there. This one has you try the same process again, but closer. And then page 3 is the final discussion of analyzing how well do you think this goes? Is this a good technique? Can we make it work perfectly? Yes or no? What do you think? No correct answer here. You can make an argument for either one, so I look forward to reading those. All right, we've got, let's see, how long is this period? Till 35, you've got 35 minutes to work. Have at it. Go ahead and turn the YouTube stream off. Nice short video for today.